Hello sir, I'm Decat Jacamos together with my fellow cadets of Group 3, and in this video we'll be having Great Circle Sailing.
So good afternoon sir, I am Decadet Dinawanaw. So the course outcome of this report is that solve problems by great circle sailing in determining courses and distance. So the learning outcome is at the end of the session is the students shall be able to determine courses and distance by great circle sailing. So importance of the topic. So the great circle routes is the shortest distance between any two places. So these circles are beneficial for following of the shortest distances between any two places and help in saving the time for the navigators. So we'll solve for the D-lat and D-long. So the given is lat 1, 42 degrees, 24 seconds south. And lat 2 is 38 degrees, 12 seconds south. So we'll solve. So same sign means minus. So we'll minus 42 degrees, 24 minutes. We will minus it to 38 degrees, 12 seconds. Wait. So the answer is 4.12. So as in we'll plot it, the destination of the vessel will go from south to north. So we'll put the label in the D-lat, which is 4.12 north. So we'll solve for the longitude. So the given is 0.12 degrees, 36 seconds east. So minus to 0.30 degrees, 48 seconds east. So the answer is 18.12. So the destination will stay in the east. So we will put the label 18.2 seconds east. So our final outcome is the D-low is 18.12 seconds east. So that's all.
So, good day, I am the Cadet Junay Academic. So, I'm going to discuss the GC initial course. So, first, we must we must know the formula, which is cos GCD equals cos D-low times cos L1 times cos L2 plus minus sin L1 times sin L2. So, we must substitute it to, so this is the what do you call that, the result of this formula. So cos 18.2 degrees, which is the 18.2 degrees is the D-low, times cos 45 degrees 24 minutes, which is the latitude 1, times cos 38 degrees and 12 minutes, which is the latitude 2, then plus sin 42 degrees and 24 minutes, which is the longitude. What I mean is latitude 1 times sin 38 degrees and 12 minutes, which is the latitude 2. So how do we get this 0.94997 times 0.73845 times 0.78585? So we must, what do you call that, in the calculator we must type the cos, then the D-low of the of the formula, which is the 18.2 degrees, and this is the result, 0.94997, and so on. It's easy to recognize because there is a formula. So we must times the we must times the numbers which it is in the parentheses. So 0.94997 times 0.73845 times 0.78585. The answer is 0.55127, and then in the second parenthesis is 0.6743 times 0.614840. So the answer is 0.41698. So we're gonna plus the 0.55127 plus 0.4168, and the result is 0.96825. So we're gonna what do you call that, the inverse cosine. So inverse cosine 0.96825, and the result is 1428.35.61. So how do we get this 868.959? So to get the distance of the nautical mile is we gonna times this 14 to this what do you call that 1428.35.61. We gonna times this to 60 to convert this to nautical mile. So to get that is we gonna times it, and the result is 868.59 nautical mile. So that's all.
So next is we'll go to find the initial course, or we will get the initial course. So since we have a GCD, so there is the formula in getting the initial course. So we'll copy the formula, which is sin our latitude 2, then minus the cos GCD, or the great circle distance, times the sen L1, then close open parentheses, divided by the sen GCD times the cos L1. So for that, we'll substitute those given values to according to the given formula. So sen, which is L2, is given, so which is our L2 is 38 degree and 12 minutes. So minus our cos, which is our GCD, is we'll only use according to the rule, which is degrees. So we'll use degrees, the values of our GCD, which is 14 degrees and 28 minutes and 35.61 seconds. So times the sen L1, which is our L1 is 42 degree and 24 minutes. So by that, we'll times or we'll multiply that. Then next is I will multiply then the other given formula, which is we substitute the our GCD, which is 14 degree and 28 minutes and 35.61 seconds, times the cos, which is our L1, which is 42 degree and 24 minutes. So by multiplying that, so we get the result, which is 0.61 and 840. So then we'll minus it to the 0.65289. So by that, so we can get the 0.3449. Then other than that, so the next will multiply, which is the 0.48 or the 389 times the point or the 0.56760. So we'll divide those results. So in 0.03449 divided by 0.1846, so which is the result of 0.18683.
So by that, we'll convert it to degrees. So in converting degrees, so we'll use the scientific calculator, which is you will click the shift, then put the 0.18683, then click the degree button. So as we can get the degree value, which is 79 degree and 13 minutes and 55.76 seconds. So southeast, or the final initial course, which is 100 degree and 46 minutes and 4.24 seconds.
In order to find the latitude vertex, we'll be using this formula. So cos LV equals cos lat1 times sine initial course. So we will be transposing the values, so that will give us the cos 42 degrees 24 minutes times sine 79 degrees 13 minutes 55.76 seconds. And with that, the product of it will be 0.72545. Then after getting that product, we'll be pressing shift cos. Then we'll be pressing shift deg in order to get the latitude vertex, which is 42 degrees 29 minutes 37.34 second south. And in order to solve for the final course, we'll be using the formula of cos final course equals sine lat1 minus cos GCD times sine lat2 divided by sine vertical distance times cos L2. So we'll be transposing the values, and that will give us these values, and upon solving this, we'll be able to get the product of 0.38447. Then we'll be pressing shift cos, and that will give us the value of 67.38915.884. Then we'll be pressing again shift degrees, and that will give us our final course angle, which is 67 degrees 23 minutes 20.97 second northeast. So for the final course of angle, the prefix is contrary to the latitude 2, and for the suffix is the same name as the tilo. So since upon finding that the position of the quadrant is in quadrant 1, which is the northeast, so the value will remain as is, and so it will give us a final course true, which is 67.38 degrees true.